So today we're going to be graphing an equation from 2 points. This is part of a 3-part process that we're going to be doing, where first we're going to take the 2 points and we're going to find the slope between the two. Also, pardon me if you can hear the band playing in the background. They've decided to pick the time I normally film to start practicing, so we're going to have some musical entertainment lulling us as we work on these problems. So again, this is part of a 3-part process where first we're going to find the slope given these 2 points. And then we're going to use that to create a formula. Now, not always is it conducive for us to have to graph these points. Like if I were to graph the 0, 0, and I were to graph the 2, 3. So if I have my 0, 0 and my 2, 3 point, what that would do is that would allow me to look at the line created between the two and say, hey, I have a line that looks like this, which then I could further work that and say, okay, what is the rise over the run? What is the rate of change as this goes up? I'd say, well, I go up 3 and over 2, which would give me a forced slope of 3 over 2. Now, that in and of itself isn't too bad. This is the graphical analogy of finding slope. But we want to find a way where, let's say these points are much further apart, or maybe so far apart that they're on a different sheet of paper. So let's look at the mathematical interpretation of what we can do to maybe speed things up a bit if we don't have the graph paper readily available. So we're going to be using the formula m equals y2 minus y1 over x2 minus x1. And this stems from the fact that our slope, as we said, is a rise over a run. And now the rise of the slope means how far up or down we go, which again, the up or down variable is going to be y. So if I go up, I'm going to take this y value from this y value and quite literally find the difference between the two y's. So I'm going to be finding the difference, or what we call the delta y. That means the change in y. And I'm going to do that over the change in x. Why the change in x? Well, the run is going to be how far left or right we go, which is going to deal with the x variable. So if I have an x here and an x here, I'm going to find the difference between them to find my run. So the difference of x's, the change in x's, is delta x. And this is going to lead us directly into our formula of y2 minus y1 over x2 minus x1. The difference of the two y's, this y minus this y, and then the difference of the two x's, this x minus this x. And this is the first part where we're actually going to be able to fill in these values. Now, the last thing that we need to remember is okay, well, what is my x2, y2? What is my x1, y1? And we figure that out by saying, okay, I'm going to label this as point 1, and I'm going to label this as point 2. So if this is point 1, this x and this y are going to be my first x and my first y. I'm going to give them little 1 placards, which basically means that they are named x1, my first x, y1, my first y. Because these are my second ones, my x and my y get that naming system. This is my second x, this is my second y. Unlike with the power, where if I had something like an x squared, this means that it's x times x. If I have x2 down here, this means it's my second x variable. So an x up at the top and the x in the bottom are two very different things. So now that I know which one's my x1, y1, and which one's my x2, y2, I'm going to go ahead and I'm going to plug these values into the equation that we've just deduced from what is a slope. Rise over run, which means the change in the rise, the change in the y's, versus the change in the run, or the change in the x's. So from y2 to y1, from x2 to x1. Let's plug those values in. And what we're going to get is when I plug in my y2, I get 3. When I plug in my y1, I get 0. When I plug in my x2, I get 2. When I plug in my x1, I get 0. And now I'm going to work this and say, okay, 3 minus 0 is going to give me a 3. 2 minus 0 is going to give me a 2. And there's my slope. And that's the first step that we're going to use over the next few segments to creating an equation for a line is, okay, let's find the slope first. You can double check that by counting 1, 2, 3 rise, 1, 2 run, and yes, I hit my point over there. So now that we understand what's going on, let's speed things up just a little bit and see how it works in real time. So I know that there's a couple things we need to do. I know I'm going to need to find my slope, which is my rise over my run, which is going to be my change in y over my change in x. Or in other words, my y2 minus my y1 over my x2 minus my x1. And I'm going to plug some values in to that equation, 4 values to be exact. And then what values do you ask? Well, remember, we're going to have to list which one's my first point, which one's my second point. And to be honest, it doesn't actually matter. If you want to call this your first point, or if you want to call this your first point, you're good. So what that's going to allow me to do is call this my first point and this my second point. We'll try one here in a minute where we're going to flip-flop them and see if it works both ways. But for this one, my first point and my second point, just to keep things easy. If that's my first point, that means this x and y are 1 and 1. This x and y are 2 and 2. There we go. So now I've got values to plug into my formula. y2, which is negative 2, minus y1, which is 0, x2, which is negative 4, x1, which is 0. And we're going to take this. I'm going to say negative 2 minus 0 is negative 2. Negative 4 minus 0 is negative 4. And looking at this, I'm going to say I can reduce this. I can take negative 2 and negative 4, and I can divide them both by a value of negative 2. So I'm going to do divide by negative 2, divide by negative 2. So 2 divided by 2 is going to give me a 1. 4 divided by 2 is going to give me a 2. Again, I notice that a negative divided by a negative is going to be a positive. So my slope here is 1/2. So instead of graphing this first and checking, we're going to get used to doing this and then checking it on the graph. So let's go ahead and let's pop our 2 points, 0, 0, right here, and then negative 4, negative 2. So I have negative 4, negative 2, and my point of 0, 0. And let's double check to see if, in fact, we get a rise of 1 and a run of 2. And I look and I'm like, well, I'm not at my second point yet, so I might have to do this again. So I'm going to rise 1 and run 2, and lo and behold, I hit my point, which means that I actually have a line. Boom. And we verified that our slope is actually 1/2. So let's check this one. We mentioned the fact that it doesn't matter which ones are x1, y1, which ones are x2, y2, and we said we could do it both ways. So we're going to try this one both ways. So if my slope is my rise over my run, which is my change in y divided by my change in x, or y2 minus y1 over x2 minus x1, I know that I'm going to have 2 possible ways to list that. I could either label my 1 and my 2, or, let's do this in blue, I'll name this my 2 and this my 1. So on the top one, we're going to do it like we've always been doing. That's going to be, let's see, y2, which is 3, minus y1, which is 1. 3, 1. My bottom one, I'm going to say this is my y2. So I have a 1 minus 3. And then 1 minus 3 on the x's as well. And we're going to see if it matters which way we do this. Well, up here we get 3 minus 1, which is 2. 3 minus 1, which is 2. 2 divided by 2, that reduces to a 1 over 1, or 1. Down here, 1 minus 3 is going to give me a negative 2. 1 minus 3 is going to give me a negative 2. A negative divided by negative is a positive 1 over 1, or 1. And so we compare the two answers. Did we get the same thing? Yes, we did. So it doesn't matter which way you label it, first point, second point, or second point, first point. You're going to get the same answer. So let's double check and make sure that we calculated it correctly. So if I have a point at 1, 1, and a point at 3, 3, so I have my point at 1, comma 1, I have a point at 3, comma 3. We're going to double check with saying, okay, my slope is up 1 over 1. Not there yet, so it's not confirmed. Up 1 over 1, and I hit it. So I'm confirming that yes, this is actually our slope. And now the cool thing about this is it doesn't actually matter how far away the 2 points are. Like I said, the graphical way is a little more intuitive, but if this point was way up over here, it's just going to be a series of up 1 over 1, 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 up 1 over 1. Every point along this line is a set of these steps. So when the graph is going to fail, the math is going to remain the same. So let's try one more. Okay. And so with this, I know I'm going to find my slope, which is my rise, over my run, which is my change in y over my change in x, or y2 minus y1, or x2 minus x1. And I know when I want to fill this in, I'm going to need to give myself some values. In fact, I'm going to need to give myself 4 values, a y2 and a y1, an x2 and an x1. So we're going to flip it around, and I'm going to say, hey, cool. First point, second point. So y2 is going to be my negative 2. y1 is my 1. x2 is my other negative 2. x1 is my 1. And so I get negative 2 minus 1, which is negative 3. Negative 2 minus 1, which is negative 3. That reduces down to a positive 1 over 1. And so let's double check to make sure we're doing this correct. If I have a 1, 1 right here, I have a negative 2 over here, and I check myself by going up 1 over 1, doesn't confirm, up 1 over 1, doesn't confirm, up 1 over 1, confirms. So now at this point, we know this is going to be a continuous line all the way up and over. Boom, and we have ourselves a line. So what I want you to do is I want you to pause the video. I want you to try number 9 on your own. Resume it when you're done and see how well you did. Okay. So I know that I need to give myself a series of points, my first and my second, and I know I need to figure out what my slope is, which is my rise over my run, or my change in y, or my change in x. Change in y is y2 minus y1. My change in x is x2 minus x1. When I plug those values in, I'm going to plug y2, which is negative 4, minus y1, which is negative 2. x2, which is negative 5. x1 is negative 1. And now what you might have noticed is that this is the big reason why we put them in parentheses, is what happens if I have minus a negative? Well, you should remember that minus a negative is just plus a positive. Minus a negative down here, again, is just plus a positive. So if I have negative 4 plus 2, That means basically I'm going down 4 and up 2. That results in a final move of -2. This means I'm going left 4 and right 1, which is a net result of -4. I know a negative divided by negative is a positive. I can divide both 2 and 4 by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. I have a slope of 1/2. And we're going to check that by saying -1, -2, -5, -4. And we're going to try out this slope of up 1 over 2. Didn't confirm it. Up 1 over 2. Did confirm it. So boom, there we go. We've got slope down. Not much else that's going to stand in our way. There we go. So today we're going to be graphing equations from 2 points, and we're going to be putting it into our slope-intercept form of the equation, which is our standard form for the equation, and figuring out what our y-intercept is based off that slope and that point. So let's go ahead and take a look. Between any 2 points, one of the first things we know in order to create a line is we need to use the slope formula, which our slope formula is m equals y2 minus y1 over x2 minus x1. What this tells us is I need to plug in some values. So I have the slope is going to be equal to 2 numbers minus 2 numbers. My second y value, xy, the second one is going to be a 4. Let's do this in red. My first y value is going to be my upper one, which is 2. My second x value, that's going to be my second coordinate, 1. My first y value, or my first x value is going to be 0. So I'm going to take 4 minus 2 is going to give me 2. 1 minus 0 is going to give me 1. So I have a slope of 2. What I'm going to do with that information is I'm going to take it and I'm going to plug it into the equation that we want to end up with. So I wanted to end up with y equals mx plus b. Now with this information, I now know my m. Unfortunately, I don't know my y-intercept just yet, but conveniently enough, I can plug in one of my points for an x and a y, plug in my m, and then the only thing I won't have is my b. Let's go ahead and see what that would look like. So I'm going to have a y value, an m value, an x value, and then my b. My m down here is going to be a 2, and then my y value is going to also be a 2, and my x value is going to be a 0. I'm going to work out this equation. 2 times 0 is 0, so that cancels out. So I have 2 is equal to b. So now I have my m and my b. I have the ability to create the equation of a line in slope-intercept form. It's y equals 2x plus 2. And there is our equation of a line in slope-intercept form. Perfect. So let's try that process one more time. So again, the first thing we need to do when we have 2 points is we need to find the rate of change between them. So y2 minus y1 over x2 minus x1. And I'm going to plug my values given these 2 points into that formula. So I have m equals some number minus some other number divided by a third number minus a fourth number. And so what we know is that my second y, so xy, xy, my second one is going to be a -5. My first one's going to be a 1. My second x is going to be a -1. My first x is going to be a 2. If we work that out, -5 minus 1, that's going to be a -6. -1 minus 2 is -3, and that also reduces down to a 2. Again, just a general theme. I worked these earlier, and we're going to have a lot of 2 slopes. Not intentional. I guess I was just in the mood for 2s when I was making this sheet, so just a heads up. So I wanted to plug it into the formula of y equals mx plus b, but as we saw earlier, I need to know the slope and I need to know the starting point. So I'm going to plug my slope in one of my points into this formula and figure out what I get. So y equals sum m, sum x, plus b. My m, which is 2. I have a y, which is 1, and an x, which is 2. And let's go ahead and solve this equation and see what we get. So 2 times 2 is going to give me a 4. And then as I work this, let's work this in red. I'm going to subtract the 4, which is going to cancel it out over there. So I'll get a negative 3 is equal to b. Boom. Knowing that piece of information, I can figure out what my equation is. It's y equals 2x, and in this case, minus 3. And there we go. So we get that. So the only other added stipulation is when we work things like this, we're going to have to pay attention to our slope. As we saw before, that when I plug in the formula, y2 minus y1, or x2 minus x1, I have to be careful of something. And we've talked about in previous videos the fact that when I plug in coordinates, I always plug them in inside of parentheses. It seems like overkill in some areas, but we'll see the reason why here in a minute. So my y2 is a negative 1, my y1 is a 3. My x2 is a 1, my x1 is a negative 4. And here's why. We'll notice that when I subtract a 3, that's not a big deal. I know the top is going to reduce to a negative 4. But the bottom, I have a positive 1 minus a negative 4. Because I put it in parentheses, I catch that that's a double negative, which means it's actually just plus a positive. So I'm adding these numbers together. I'm not subtracting 4. I'm going to get 5. So now I have a slope of 4/5. So I'm going to do what we've been doing, except for I'm going to slide it up a little higher to give myself some room. And I'm going to plug, this lower one in this time because 1 and negative 1, those are easier to work with than the negative 4 and the 3. Could you plug in the negative 4 and 3? Yes, you'll get the same answer. I'm going to plug in the smaller numbers because, again, they're going to be easier to work with. So if I want to plug it into y equals mx plus b, I'm going to have to plug in a y, an m, x, and a b. So let's see. My m is negative 4/5. My y is negative 1. My x is 1. What that's going to allow me to do as I work this, it's going to be a negative 1 equals negative 4/5 plus b. Now what we could do is I could add the 4/5 over there, and basically I would need to find a common denominator. But the skill that I like to teach right here, because again we're going to see this later on with systems of equations, is I like to just go ahead and eliminate that fraction. Let's clear it away. And if that fraction says divide by 5, I can get rid of that by multiplying everything by 5. So that poofs away. I got rid of it. 5 times negative 1 is negative 5, is negative 4 plus 5b. And what this allows us to do is allows us to scale up our equation so that we can work with it a little more neatly, I guess you could say. So let's add 4, which is going to cancel that out over there. Negative 1 equals 5b. And the next thing I'm going to do is I'm going to divide by 5, which cancels that out right there. I have a negative 1/5 is equal to b. And again, what this does is it removes the uncertainty of working with fractions, and it says, hey, I'm going to use a skill that I'm going to use later on to get rid of it, and it'll save it for the very end. So I have an equation of y equals negative 4/5 x minus 1/5. And there we go, and there's our equation. So remember, 2 things to catch for here. When I have minus a negative, it turns into plus a positive. And if I have a fraction and I don't want to work with fractions, go ahead and multiply each thing in our equation by that denominator, and it'll get rid of it for you and save it till the very end. Okay? So what I want you to try is I've got 2 more. I want you to pause the video, try and work these, paying attention to those 2 things that we just worked through. And then when you're done, unpause the video. I'm going to put the work down here and see how you did. Okay, so by now you should have worked these out, and let's see how well you did. So again, with either one of these, I'm going to go ahead and find my slope of y2 minus y1 or x2 minus x1. And that's going to mean I'm going to take two numbers and subtract them. My y2 is 2. Oh, make sure I do these in something that shows I'm substituting them in. Y1 is negative 1. I have a 3 and a negative 3. Again, the first thing you should notice when I have minus a negative is going to be it's going to turn that into plus a positive. Same thing up here, plus a positive. So I'm adding these numbers together. So m equals 3 over 6. This is going to be a 1/2. I'll double check and make sure I didn't give you another 2 slope. So I'm going to take that 1/2 and I'm going to plug it in, as well as I'm going to plug in the lower one again, simply because they're both positive. So I know I'm not going to have to deal with any negatives or any double negatives possibly in my equation. So out of my y equals mx plus b, what I have is I know that my m is going to be 1/2. My y is going to be 2. My x is going to be 3. I'm going to simplify this before I go ahead and clear that fraction out. So I know I have 2. Well, I know that 3 is understood to be over a 1. So 3 times 1 is 3. 2 times 1 is 2 plus b. So I'm working with that information. I'm going to look at this. I'm going to say, hey, I don't want to deal with a fraction, and I want to practice something I'm going to be using later on. And I'm going to clear a 2 by multiplying everything across the equation by 2. That becomes a 4. That canceled out, and I have a 2b. Next thing I'm going to do is subtract my 3. Cancels that out right there. Extend that a little further. So I have a 1 equals 2b. And then the last thing I'm going to do is divide by 2, which is going to give me, separate that step, a 1/2 is equal to b. So I have all the information I need to write my equation for my line. I have a y equals 1/2 x, and then that's a positive 1/2. And there we go. We have all our information. So see how you did on that. The last one here is basically more of the same. So second version, let's see how we did on this. So y2 minus y1, x2 minus x1. I'm going to take my slope and plug in my 4 numbers. I'm going to subtract them. I have a negative 3 and a 0 for my y's, a 1 and a negative 1 for my x's. I notice that my minus a negative turns into plus a positive right there, which is going to give me a slope of negative 3 over 2. Boom. Again, we take that information, we plug it in, as well as I'm going to plug in this top one because I'm going to hope that 0 is going to make something easier to deal with. Not sure if it will, but anytime I see a 0, I'm going to try and plug that one in instead of anything else, because typically they do make our lives a little easier. My m is negative 3/2. I have a y value of 0, and I have an x value of negative 1. So what we see here is I'm going to be multiplying these two numbers. I'm going to put that over a 1. Negative 3 times negative 1 is going to give me a positive 3. 2 times 1 is going to give me a 2. Hey, and lo and behold, I don't need to worry about combining denominators, so plugging in that 0 did make our lives a little easier. I'm going to go ahead and subtract those 3 halves. And because I'm subtracting from a 0, it doesn't really matter. It's just going to be whatever that thing is. So negative 3/2 is equal to b. Awesome. So I have a y equals negative 3 halves, negative 3 halves x minus 3 halves. And so check, see how you did? And there we go. So today is going to be an extension of what we did the previous video. We're going to be doing a formula using the point-slope formula when given 2 points if we want to create the equation of a line. What we did last time was we used the slope-intercept. This time we're going to use the point-slope. And we're going to go ahead and we're going to show a proof of why we can do this and why it's going to save us a little bit of time in the long run to be able to plug it all in all at once. So our proof for this is the fact that if we have any sort of a line based off right here, let's put 2 points. So let's call this point 1 and point 2. Point 1 we're going to label as x1, y1. And normally we would label point 2 as x2, y2, but today basically we're just going to label it as some generic x comma y. So these are still differentiated. I still have an x and a y. I still have a different x and a different y. So I want to be able to create a line between these 2 points. So if I graph a line using these 2 things and these 2 things alone. So let's go ahead and let's figure it out. First off, we need to be able to find the slope between the 2, and that's going to be where this equation comes from. It's going to come from our equation for slope, which was rise over run. So we know the fact that the slope is going to be the rate of change going up and then divided by the rate of change going to the side. So let's rewrite that as the slope is equal to, now normally it'd be y2 minus y1, but in this case I'm going to do let's do this in red, y minus y1 over x. And again, normally we would put x2, but in this case it's just going to be a generic x, x1. So now I have y and x in there. And now in previous videos, what we've done is we've gone over and we said, hey, if we have an equation like 1/8 x plus, let's say 7/6 equals 4, and we don't want to deal with fractions. What we do and what we've done is we take the entire equation and we multiply it by one of these denominators. So let's say an 8. What that does is that cancels out that fraction, and then we do it again for each consecutive fraction. So we're going to do that same skill up here. We're going to, let's pick purple. We're going to take the entire equation, and I'm going to get rid of this fraction by doing what we just did over here. I'm going to multiply by whatever we divided by. So I'm going to multiply times x minus x1. And so what's going to happen is that's going to pop up over here and over there. And so we have, let's see, I'm going to have an m times x minus x1 on the left. I'm going to have, and as these are going to cancel out, I'm just going to have a y minus y1 on the right. And now the only thing that we're going to do now is we're going to swap the sides. I'm going to write this over here. I'm going to say, okay, y minus y1, and I'm going to write m equals x, m times x minus x1. Kind of ignore what I just did right there. And this is going to be your equation for point slope. So let me go ahead and write it over here. So our point slope form, point slope form is going to be under the form of y minus y1 equals m times x minus x1. And now what I've done is I've color-coded it so you can see exactly where the name comes from. This form, given a point and a slope, we plug in our point and we plug in our slope. Boom, we have ourselves an equation of a line. So let's go ahead and let's give that a shot on one of the following problems. let's look at this. So I have my 2 points, and so my first step is going to be saying, hey, I need to find the slope. I'm going to say y2 minus y1 over x2 minus x1. And now that we've created the generic formula, I'm going to go back to doing my x2 and y2. The only reason I didn't up here was so that we know that we have an x and y left over for our equation. We're not going to fill in everything, otherwise we would say 2 equals 2, or 4 equals 4, or 6 equals 6. And we don't worry about proving that it is equal. We want to leave an x and a y in there. So here, not necessarily too worried about it. I'm going to plug in my values, and we remember the fact that in the coordinates we have x and then y. So I'm going to have my first y, my second y, so -3 minus my first y, which is 1. On the bottom, I'm going to do the same thing. I'm going to take my second x, which is 0, and I'm going to subtract my first x, which is 2. Okay? So I have the slope is -3 minus 1 is -4. 0 minus 2 is -2. I can reduce that. -4 divided by -2 is 2. There we go. And so now we're going to pop it, because I have my slope, and I have 2 actual points, so I can plug either one of those into my x1, y1, and I can get myself my equation. So let's go ahead and do that. So my y minus y1 equals my new m times x minus my x1. And let's plug in these 3 bits of information. So y minus my y1, which is 1, equals my slope, which is 2, x minus my x1, which is also 2. There we go. Boom. And normally I'm going to include these in parentheses up front, because if we ever have a negative coordinate, we want to make sure that we're going to catch a double negative. So nothing really changes right here. It's actually just y minus 1, 2, x minus 2. So our first step as we solve this is we notice the fact that we have a 2 sitting outside right here. So I'm going to distribute this 2 inward. Distribution, remember, means I'm just going to have to multiply more than once. So I'm going to multiply the first time. 2 times x is 2x. Multiply the second time. 2 times 2 is 4. And so I get right there. The last thing I do is I'm going to add my 1 to get rid of the 1 from over here with the y. That's going to go ahead and cancel out. And so I'm going to have a y equals 2x. So -4 plus 1 is going to be -3. And there we go. We've created a form in slope-intercept using our point slope. Perfect. So let's do one more just to make sure we got the process down. So our first process, if we want to write an equation for a line, is we have to find the rate of change between these 2 points. So we have to find the slope. So m equals y2 minus y1 over x2 minus x1. And I'm going to fill in my points. There we go. So my second y, I have x comma y. I'm going to go down to the second one. So that's -1. First y is -3. x2, so I'm x and then my second x, that's going to be -3. And that's going to be -4. Cool. And so the reason, again, why we put these in parentheses is that we catch the fact that there's 2 negative signs right here. And we know that anytime there's 2 negative signs, that turns into plus a positive. So what I'm actually dealing with is I'm actually dealing with -1 plus 3 over -3 plus 4. And the reason why we do this as we simplify, so 2 over 1, which is 2. We get another slope of 2. The reason why I write the parentheses is because what a lot of students do is they say, okay, x minus x1. And they'll come over here and they'll write, okay, so x2 is, actually let's start with the y's. They're going to say y2, so we have -1, and they're going to subtract y1. And they're like, well, conveniently, y1's already negative, and so they just subtract 3. Now remember, if I look at the formula, that's saying my y2
is -1 minus my y1, which is 3, which is not what my y1 is. I'm saying that it's a 3 when really I just meant to put a negative sign. So we know we don't want to do that, and the way I avoid that is by putting parentheses. The other reason why, even if you don't put parentheses and you're like, hey, I just write 2 negative signs, again, students will write something like, okay, y2, which is -1, and they'll put minus -3, and then they'll look at that and they'll say, is that 2 negatives, or did I just write a really sloppy negative sign? In their head, they're thinking, did I do -1 minus 3, question mark? And they'll just basically revert back to doing the same thing. And we know that both of those we don't want to do. We want to catch the double negative. So generally when I input or when I substitute any values, I go ahead and put the parentheses to catch that mistake. So let's go ahead. Now that we have our slope, we're going to plug it into our formula for point slope. So I'm going to say my y minus y1 equals my m times x minus x1. And I'm going to plug in my slope and my 2 points. So let's go ahead and plug in a slope of 2. I have a y1, which is -3, and I have an x1, which is -4. Let's fill in the rest of this formula. And so again, it helps us catch that minus and negative, and that minus and negative cancel out. And so as we move forward, I'm going to distribute this 2. So I have a y plus 3. And when I distribute, I'm just multiplying more than once. So I get a 2x. Now that that's plus 4, 2 plus 8. And again, my last step is subtract the 3, which cancels that out over there. I'm left with y equals 2x plus 5. I took the point slope form and I converted it into slope-intercept. Awesome. So let's try just a little bit more. So what I want you to do is I want you to try number 5 and number 7. When you're finished, pause the video and then resume it when you're done and see how well you did. I'm going to give you a few seconds to knock that out. Okay, so let's see how you did. So what we're dealing with right here is I know between any 2 points I have to find the rate of change, which means I have to find the slope. I'm going to plug in my y2 minus my y1. So I'm going to get my 3 minus my -3 over my x2, which is 0. I just touted about how I always use parentheses, and I didn't use parentheses up there. So I have 0 minus another -3. Now we catch ourselves and we notice, hey, with these double negatives, those turn into plus positives. So I'm actually dealing with 3 plus 3, which is 6, and 0 plus 3, which is 3, and that reduces down to another 2. Boy, we're getting a lot of 2 slopes here. I guess I was feeling it when I was making these. And so then now that I have a slope and a point, I'm going to plug it into my point slope formula. So I'm going to say y minus my y1, which is -3, my slope, which is 2, x minus my x1, which again is -3. We're going to catch the fact that these minus negatives become plus positives. So that's actually y plus 3 over here. And that's actually x plus 3. We're going to go ahead and we're going to distribute, which means I multiply 2x and I get a 6. And then the last step is I subtract not a 6, a 3. That's a 3 if you believe it. I was going to write subtract 3 and I looked over at the 6 and wrote the 6. So that cancels out. Y is equal to 2x plus 3. Boom. So we've taken our equation in point slope and converted it into slope-intercept. So hopefully you got that in number 5. Number 6 was pretty much the same style. Number 6, when we found our slope, y2 minus y1 over x2 minus x1, we got, let's see, 5 minus a negative 5 over 4 minus a negative 1. We caught ourselves where we're actually adding these things. So we had m equals 10 over 5, and again, not sure why all the slopes happen to be 2 today. We're just going to go with it. Plug it into our general formula. So y minus a negative 5 equals 2 times x minus a negative 1. Those double negatives, we catch ourselves. So we said y plus 5 is equal to, I'm going to go ahead and distribute, 2x plus 2. My last step is to subtract the 5 so that I can isolate that y. And I get y equals 2x minus 3. Boom. And there we go.
So today we're going to be graphing equations giving 2 points by putting it into point slope form and graphing it. So everything that we're doing today is nothing new. We're just taking what we've learned in some previous videos and putting it all together. We know how to make an equation from these 2 points. We know how to graph an equation in slope-intercept form. Now we're going to combine the 2 skills. So let's go ahead and get started. I know that with any 2 points, I'm going to need to use the formula for slope so I can find the rate of change between them. So I'm going to take y2 minus y1 over x2 minus x1. So I'm going to say, okay, my slope is some number minus some number over some number minus some number. My second y is going to be 3. My first y is going to be negative 1. My second x is going to be 2. My first x is going to be 0. Actually, I should have done these in a different color so that way they stick out a little bit more. They don't blend into the background quite so much. So I guess that works. So then the next thing we're going to do is we're going to say, hey, we notice that we have that minus a negative, which we're going to turn into plus a positive. And so that's actually going to be 3 plus 1, which is 4, over 2 minus 0, which is 2. So we have a slope of 2. The next thing we're going to do is we're going to plug it into point slope form to get the equation of our line. We know the equation for point slope form is going to be y minus y1 equals m times x minus x1. So I'm going to say, okay, y minus something equals some m times x minus something. My y1 is going to be negative 1. My m is going to be 2. My x1 is going to be 0. Awesome. So the first thing I notice is that I have minus a negative. I'm going to go ahead and add that, which leaves me with a y plus 1. And then as I notice, I'm going to have to distribute this 2, which is going to leave me with 2 times x is 2x, 2 times 0 is 0. So I'm just not going to write anything. The next thing is I'm going to subtract my 1. Because those are not like terms, I'm going to leave it over here. And so it's going to leave me with a y equals 2x minus 1. There's the equation for our line. This is going to tell us all the information we need to graph it. It's going to tell us that I need to put a point at negative 1. And it's going to tell me I need to go up 2 over 1 from that point as many times as I can. And if I run out of room going up and over, up and over, up and over, I can reverse both those. Instead of going up, I can go down 2. Instead of going right 2, I can go back. And lo and behold, that's still in line with the rest of my points. So I can go down and back instead of up and over, which is going to give me a line just like that. Okay. And then there's 2 important points that we want to label on our line. The first important point is I want to go ahead and label that y-intercept, 0, negative 1. The second important point is I want to label my line either down here or up here. I want to label it by one of my arrows. So y equals 2x minus 1. And that's just going to come in handy when we graph more than one, is you typically label it by one of the tips or by one of the tails. So Let's try one more of those. We're going to take a formula for slope, so m equals y2 minus y1 for x2 minus x1, and I'm going to fill it in. So m equals something minus something over something minus something. y2 is negative 2, 0, negative 1, 0. So my slope is negative 2 over negative 1. Our slope is 2. Now I'm going to take that information and my x1, y1, and I'm going to plug it into the point slope formula, which is y minus y1 equals m times x minus x1. So y minus whatever my y is equals m times x minus whatever my x is. Let's see, so my y1 is going to be 0. My m, we just figured out, was 2. And my x1 is also 0. Now, what I notice is that when I distribute over here, first off, I don't need to write this 0. It's just completely unnecessary. I'm going to have a y equals 2 times x is 2x. 2 times 0 is 0. I don't need to write that either. I'm already done with my equation. This tells me a couple things. Again, without a y-intercept, there's no b. So I know there's an understood plus 0 just sitting out there in imaginary space. So my vertex, or not my vertex, my y-intercept is going to be right there in the dead center. I know my slope is going to be up 2 over 1, up 2 over 1. And if I don't have any space, instead of going up, I can go down. Instead of going right, I can go left. So down, left. Boom. I have a nice little equation graphed. Let's go ahead and graph these points. Draw my arrows on the end. Remember, we talked about the arrows being necessary to show that the graph continues on. I'm going to label my y-intercept, which is at 0, 0. And I'm going to put either arrow, I could put it down here, y equals 2x. Label my line. Okay? Perfect. So let's do one more. So this one, they're all positive numbers. If I plug in my equation for my slope, y2 minus y1 over x2 minus x1, I'm going to have to plug in some values. Something minus something over something minus something. And now the cool part is we've always been doing it as first coordinate, second coordinate. It doesn't matter as long as you're consistent. If you wanted to, for some reason, say that this is your second coordinate and this is your first coordinate, you can. So in that case, my y2 is going to be a 1. My y1 is going to be a 4. My x2 is going to be a 2. My x1 is going to be a 3. So I bet you if you're working this the other way, compare your answer with what we're about to get and see if you get the same thing. And I bet you the answer is yes. So here our slope is going to be negative 3 over negative 1, or just 3. Did you get the same thing? Probably so. So now let's plug it into our formula over here. Y minus y1 equals m times x minus x1. And remember, we've flipped it. So instead of the 1's being on top, I've made this the first coordinate, which is 100% legal to do. So let's try it out. If you work it the other way, compare your answer and see if you get the same thing that we did. So y minus my y1 is going to be 4 times m. X minus x1 is going to be 3. I already know I'm going to have to move some stuff over, so I'm going to draw my line. So it's going to give me a y minus 4. I'm going to go ahead and I'm going to distribute my 3, which is going to be 3x minus 9. And then I'm going to go ahead and add my 4. Just going to cancel that out over there. And I have a y is equal to 3x minus 5. And so what did you say? Did you get the same one even if you used the reverse? Generally, the answer is yes. And by generally, I mean yes. The answer is always going to be the same. So I'm going to put a point way down here, -5, and I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. I'm going to connect all these points with a nice solid line. And I'm going to label my 2 points, my 0, -5. I'm going to label my line as y equals 3x minus 5. Boom. So now that we've gotten a good handle on it, why don't you try this last one on your own. Pause the video, resume it when you're done, and see how you did. Okay, so let's see how well you did. I have a slope, just like that. I'm going to plug in some values. We're going to go back to the original way, where I'm going to say 1 and 2, just because it's visually more easy to do, and it confuses me less. So 3 minus 1, 3 minus 5. Because having to mentally flip them upside down each time gets a little long. -4 over -2. That's going to give me a +2 as my slope. And that way I can plug it into this formula over here, which is going to be y minus my y1 equals m times x minus my x1. My y1 is going to be a 1, my slope is a 2, and my x1 is a 5. Go ahead and distribute my 2. So I get a y minus 1 is equal to 2x minus 10. And then I'm going to go ahead and add my 1, which is going to cancel that out over there. And I'll get y is equal to 2x minus 9. And that looks awesome, but the only problem we'll run into is I only have 5 spaces. How do I fit 9 on a grid of 5? Well, I can just, instead of making each block worth 1, let's make them worth 2. So I can say, hey, 2, 4, 6, 8, and then half a block down is 9. Perfect. And then the other thing is I can still count by blocks, because we know that a slope of 2 over 1 is equal to 4 over 2. So 4 would be 2 blocks, and 2 would be 1 block. So I know going up by 4, which would be 2 blocks, and over 1, it still works out because these are mathematically equal. So with scales, it allows you to work in ways that you normally wouldn't be able to, or normally would be a little more tedious than you would run into, because the cool part about them is they're consistent. I'm going to connect all my points. Draw my arrows. I'm going to label it as y equals 2x minus 9. And label my point down here as 0, -9. Boom. There we go.